So all we're doing in here is adding and subtracting real numbers. The difference is we're applying this to a number line, okay? Number line meaning starting from 0, this direction going positive, this direction going negative. Are we clear?
Yeah.
So 0, 5 would be over here, negative 5 would be to the left, okay? The negatives increase. So negative 3, negative 4, negative 5, negative 6, okay? Just like positive, it goes 3, 4, 5, and 6. It builds up this way, right? And negatives builds up this way. Is that clear? Okay. So looking at this first example, these are actually fairly easy to do if you know the rules. Right, Padilla? So we have negative 3 plus 6. So we're going to make a number line. The very first number is our starting point. Is that clear? We are not starting at 0. We're starting at negative 3. Okay? So we're going to take negative 3 and we're going to add 6. What direction I tell you positive goes? To the right, correct?
Yeah.
So from this negative 3, we're going to add 6 and we're going to end up at 3. 1, 2, 3, 4, 5, 6. So our answer is 3. That's how we use a number line to solve problems. Is that clear?
Yeah.
Okay, starting point, first number. Okay? And then this is directions of what you need to do. From this negative 3, we're going to add 6. Okay? So let me see thumbs up or down. If whether you got this, you're ready to move forward. Okay, let me cover it one more time, okay? We're looking at these numbers. We're going to start with these numbers. So we're going to draw a number line, 0 to negative 3, and then we can go to whatever. So I'm going to take this one, I actually end up taking this one to 4, right?
Yeah.
So we start at this number. Do we know how to find negative 3 on the number line?
Yeah.
Yeah. 0, negative 1, negative 2, negative 3. This means I'm starting at negative 3, draw a line. Okay? Now it's plus, so we know it's going this way. The only thing that's different is we're going to count the spaces. 1, 2, 3, 4, 5, 6. This is where we stop. Our answer is 3. Okay? So minus 3 plus 6 is 3. We can see it on the number line. Okay? Pretty straightforward, right? Okay. 2 rules. Okay? We're starting wherever the number is, in this case negative 3, and we're adding 6. So if it's adding, we're going to the right. Okay? If it's subtracting, we're going to the left. Okay? Okay, next one. Minus in parentheses, negative 9 equals 7. How many see this and say, Seeing it on the number line makes it easier. Okay? It gives us a visual concept of what's happening here. What number are we starting on?
2.
Minus 2. So our starting line is negative 2. Now, what type of math is parentheses? Yeah, multiplying. So we have a negative times a negative. It turns this positive. Okay? What direction is plus? Yes. So from this negative 2, we're going to add 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our answer. If we take 2, negative 2, and we add it to 9, our answer is 7. We see it on the number line. Okay? So we're starting at negative 2, and we're adding 9. So in your notes, I want you to add this. I want you to put, if I have 2 negatives, it turns it positive. If you have parentheses, okay? However you need to write that. If you want probably the easiest, a negative times a negative is a positive. Write that down. Okay, this next one. So many students struggle with, it's negative 7 plus negative 13. This is where the number line comes into effect. The number line helps us. Same exact rule, where am I starting at?
3.
Negative 3. So I'm starting at negative 3. Now it's saying I'm going to add negative 16. Well, what direction is negative? To the left. So we're going to go from here, and we're going to add 16. So if I count this all out, I'm going to get to 16. I'm ending at 19. Isn't this way easier than looking at this problem and trying to come to an answer? What do I tell you guys all the time? It's, you borrowed $3, you borrowed 16, right? That's a good way to remember it. Mom lent me $3. I got to go back to her because I want to go to movies. I need 16. Mom goes, you know what, you owe me, right? Well, what's the answer? Yeah, you're 19, right? Because you borrowed 3 and you borrowed 16. But this is a way to see it visually. Once again, we're following the rules. We're starting at -3. That's our starting point on the line, not 0. Okay? We're going over 16. We're ending at 19. Any questions? Let me see thumbs up or down. Okay, you follow the rules. There's not a whole lot to know, right? Start at 3, subtract 16. If it's negative, it's going this direction. If it's positive, it's going that direction. Okay? Okay, this one. Using a number line, but doing substitution. Thank you.
That's a crucifixion.
Oh, man. Thank you. Thank you. Okay, x plus 7. All right? It's a problem, and that's telling us to substitute -13 for 7. Okay? So all you're going to do, you're going to rewrite this problem, you're going to get rid of the x, and you're going to write -13. Okay? Does everyone understand? Levi, stay with me. So -13 plus 7. Notice, isn't this the same? Yeah. It's just saying, it's asking me to solve this when x is equal to -13. So we start at -13. Where do I start in the number line? -13, yeah. It's always the first number. So we're starting at 13, and we're adding, what direction do we go in the number line?
Right.
This way, right?
Right.
We're adding. We're going to the right, Levi. That's left. Left means you're going negative. Now think about this. 0, -1, negative. You're going further and further in the hole. Versus going to the right is further and more stacks, right? More and more money. Okay. So with that said, once we plug this in here, we start at -13, we add 7, there's our answer, it's -6. Now I know our minds, that's a little hard to understand, right?
No, I just thought that was a negative.
Yeah, positive 7. Let's talk about this for a minute. I'm going to give you one other rule that's sometimes helpful. Jose, look. -13 plus 7, right? What number's larger?
7.
7.
I don't mean conceptually larger on a number line.
13 should be.
Yes, the 13. So if you remember that the larger one retains the symbol, this answer is going to be negative. So then you could just take 13 and subtract it from 7. You know it's negative. Okay? Larger one retains the symbol. So if this was reversed, if this was a -7, the larger number would be positive, right? So that's another way as well. But this gives you a conceptualized process of seeing what happens here. We're starting at -17. We added 7. We ended at -6. Any questions on this? Are we good? Good deal? Yes? Okay. All right, next one. Now remember what I said about larger? Which one's larger here, the 7 or the 10?
7.
Okay, so we know this one has to be negative, right? I borrowed 10. I paid back 7. I still owe them 3, right? So once again, following our rules, we're going to start at net 7 on the number line. We're starting at 7. We're going to subtract 10 to the left-hand side. This tells us what direction to go. We're going to the left. When we finish, we end up at -3, right? Start at 7, add 10. If I count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I end at -3. We use the number line like a calculator. We use the number line to solve the problem. Are we clear? Okay. All right, E. This is very similar to this. The only thing that's different is we have a negative here, right? Anytime you have parentheses, this is a negative times a negative, it turns it positive. Okay? So you're going to rewrite the problem. You're going to just write 3 minus 3 plus 12. Which one's larger, the negative or the positive?
Positive.
Yeah, because the 12 is bigger, right?
Yeah.
So we can subtract 12 from 3. We know our answer is positive. That's the way I get asked this question all the time. How do I put negatives in the calculator? You don't need to. If you know what number is larger and you know the rules, you're fine. Okay? Any questions?
No.
So if you have a negative and a positive, is it a negative or what is it? Positive?
It depends. In adding and subtracting, there's no negative times a negative. Okay? This, because it's in parentheses, makes it multiplication. When it comes to addition and subtraction, it's whatever the larger one keeps the symbol. Okay? So, like this one, this becomes negative, negative, turns it positive 12. I know my answer has to be 12. Okay? Now, if this were negative and this one were positive, then my answer would be negative. Whichever one is larger. Clear? Okay. Next one. Very, very similar to this one right here. We have a problem that's x minus 22. Okay? Then it's telling us x is negative 11. Now let me show you something. We plug in this negative 11 for x, negative 22. When you see two negatives, your answer is negative. Okay? Always, 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 always. I borrowed 11, I borrowed 22, now I owe 33. Is that clear? Do not get confused. Number one mistake is, oh, it's a negative by a negative. It is not a negative by a negative, okay? It is a negative, subtract another number, right? Okay. And I write down the rule here. I say negative increase stays negative when adding and subtracting. If the two negatives, you're just the negative is getting larger. Okay? Fractions. Fun, right? Yes. No. When you have fractions, we have to have common denominators, right? We have a common denominator of 3 in this case, okay? When we're two negatives, what do we do here with these two negatives? We added them together, right? 22 plus 11, 33. Same thing happens in a fraction, okay? If they have a common denominator and they're both negative, they're going further on the left on the number line, okay? So we take this 2/3 and we add it to 1/3. Well, what's 2 plus 1?
2 plus 1 is 3.
Okay, we don't touch the bottom, we just carry it over, and we have negative 5. So this is negative 5, 3 over 3. Well, what's 3 over 3 over 3?
One whole.
It's one whole, yeah. Because your part is whole, your number is whole. Very good, Levi. This becomes 6. The answer is actually negative 6.
Oh.
One more time, one more
I
time.
get it now, I get it.
Anytime your fractions are both negative, you're going to be adding them together, okay? In this case, both of them have a 3. So they have a common denominator, we can add them, because that's a rule. You have to have a common denominator to be able to add or subtract fractions.
What if they didn't both have a 3?
If they didn't, then we'd have to convert one of those fractions to get to a common denominator.
Can you do one of those?
I think yeah, right there. We'll get there in a minute. So, 3, 3, nothing to do here, we just add this. So 2 plus 1, 3, 3 over 3 is one whole, 5, we increase the 5 to 1, negative 6. Okay? All right. We have a mixed number and we have a fraction. Okay?
Another question.
Yes.
What if those two top numbers didn't add to 3 and made that one whole and made an improper fraction?
Excellent, excellent question. Does everyone understand what he's asking? What he's saying is, what if we added these two numbers and it was an improper fraction? Like this was 4. Excellent. Well, that 4 would turn the 5 into a 6, right? So if it's improper, you've got to turn it back proper. That's good. And we'll kind of get there. Don't worry about that now. Okay, look at this one. We have a whole number and we have a fraction. You love those because they're very, very easy to do. What do I mean? Isn't 4 and 8 over 8 the same thing as 5? Hey, it is, right? Because there's part whole, that's 1 plus 4, which is what? 5, right? So anytime you'll have a whole number subtracted by a fraction, it's very easy. You remember in grade school where you borrowed? You borrowed from 1 to carry over, so you could actually subtract?
Yeah.
Same thing's happening here. So I borrowed from this 4, or excuse me, I borrowed from the 5 to get 4, and I put 8 over 8. Is it always 8 over 8?
Yeah.
It's always 8 over 8 because this is a part in the whole. These two numbers are identical to each other. Conceptually, how can you think about this? If Levi has $1.04 and Jose has $2, do they have the same money?
No.
Yes.
They do.
Oh wait, $1.04 what?
You have $2.
Uh-huh.
He has $1.04.
That's two.
Wait, isn't 4 quarters just the dollars? So
He has $1.04.
Oh.
So he has $2. You have $2.
Oh.
You have two whole things. He has a whole thing and his parts equal to a whole. It's the same thing. So it's the same thing here, Jose.
25 plus 25.
So 5, we're 5 and we're 8 over 8, so this is the same, okay? So now we just subtract the top. 8 from 3, which is 5. We don't do anything with the 8. We don't do anything with the 4. We're done. By the way, same rule. Larger one retains the symbol. The 4 is larger than the fraction, so we know this one's going to be positive. Okay? You're going to get plenty of practice on this.
Hey, but what do you mean by the
Are we
four
doing the
bar?
right now?
Yes, once I get through this, 2 more.
How did you
Ask, Levi, ask me one more time.
how did you do that 4 bar that you borrowed.
How I borrowed? Okay. I have -3, 8, and I'm 5, right? So I need to have a common denominator of 8, right?
Mhm.
So I'm going to borrow from this 5. I'm going to make this 4 and 8 over 8. Aren't these numbers exactly the same thing?
So like, what'd you do to make it 4?
I borrowed from 5, took 1 away from it, and I made it 4. Then I need, just like my dollar and 4 quarters, same thing here, 8 over 8. That's 1, that's 4, this is 5, which is the same thing as this.
What'd you do with the 3 over 8?
Okay, I'm not there yet, but did you understand how I got here? I just borrowed from this 5 and made it 4, 8 over 8, right? These two numbers are the same. Just like-
okay, I get you now. You use the same denominator, but you made it the numerator and then just made it 1 whole.
You got it. And this is the easiest way to do it because we don't really need to do anything else, right?
Right.
These are the same numbers.
Alright.
They're identical, okay? Now, we don't do anything with the 4 now. All we're going to do is subtract the numerators. So we take 3, we subtract 8, and we get 5, right?
Yeah.
We don't do anything with that 8. We carry the 4 over,
So
we're
you
done.
just made it proper then.
Yep. Yes. Absolutely not. Okay, now, this is where we go into common denominators, okay? So we have two things here. We have 2/3 minus 5 over 6. We can't subtract these because they're not like each other, okay? That means we need this common denominator to be 6. Why 6? Because 3 goes into 6, right?
Yeah.
So we leave this equation alone and we focus on this equation. So remember how I told you about stacking problems on top of each other, what you did in grade school? You're going to do the same thing here. You're going to take the 2/3 and the minus 5, 6, you're going to stack them on top of each other, okay? We need this to be 6, so we write 6. 6 over here. What do we have to do to get 3 to 6? Well, if we multiply 3 times 2, we get 6, right? So we're going to do the same thing. What we do to the bottom, we do to the top. Which I just did that wrong. So 2 times 2 is 4. Write that. Yeah, I did. Caught myself. I actually intentionally did an error here, and I wonder if I did it here too. Because the answer is that. Okay, so 2/3, 5, 6, stacked on top of each other. We needed 6. So let's do it. Let's do it right from how we do it, looking at the problem. I think that's going to make it easier understood,
You went to math and
right? Okay, what's my first one? Everyone look up, please. What's
3.
okay? So we're going to write.
Damn.
I can't win.
Oh, miss.
Yeah, move real quick for me, please.
He's gonna shoot.
Okay, why are you on your phone?
Because I was texting someone.
Okay, go put it on my desk, please.
Damn.
Quick, I want to make sure you get this. Okay, so here we got the first problem. We're going to put it on top. So we're 2/3, right? And then we're going to write minus 5 over 6. Okay, draw a line. We need this to be 6. So we're not going to do anything with the denominator. All we're going to do is we're going to write 6 over here. Does everyone understand what I did so far?
So yeah.
I need these numbers to be the same, so I'm writing 6 over here, right? Well, what is 6 divided by 3? 2. So in parentheses, I'm going to write 2. Well, is 3 times 2 6? Yes. So what we do here, now we're going to do the top. So what am I going to multiply the top by? 2. So this becomes 4, right? This one's going out too. So, notice something. You know I'm recording, right? Take your hoodie off. So we're 4, 6 minus 5 over 6. Okay, so this one's larger, so we know the answer is going to be negative. So we take 4 from 5, which is what?
1.
And we don't do anything with the denominator because we got it to a common denominator at 6. We're minus, we're done with the problem. We need another pen already. Any questions? Common denominators. You're going to get enough practice here. I have another one, but it's in a box. Okay. There's no math involved in this one. This is called an absolute power, which is also another one of your vocab words. Let me explain what an absolute power is. Levi, do you have any money on you?
Yeah.
Can you? Would you want? I'll give it back to you. I want to give you an example. If you have some money, come bring it to me. I promise you. Stand right here. I'm going to hand it right back to you. I want to show you something.
Last time he forgot to give it to me, I had to ask him.
I know, and you have some bucks. I could have got lunch.
Yeah, you could
Snack.
have gotten away with it, huh?
Okay, so Levi has $1 in his hand right now, right? So he has $1, correct? Come here, Levi. Come here. he's gonna loan me this dollar. How much money does he have?
Dollar.
Does he?
No, he has zero.
He has zero. But does he have value?
Yeah, I have more.
I
He
mean,
has value if I pay him back, right?
Yeah.
So if I pay him back, he's owed $1, right? That's what absolute value is. Any time you have two long little lines and it's negative, it comes out positive. Okay? Okay.
You gotta run. You wanna talk to him?
Yeah.
Pocketed my dollar.
Yeah,
It's
what did
dragging
he
my
laugh at me?
Okay.